Hello everyone and welcome to my video presentation on home and building automation using ARM and AVR microcontroller. My name is Sriram Subramani and I am a graduate student in the Department of Electrical Engineering at the University of Buffalo. This presentation is for my finals term paper in EE 500 Embedded Systems course. Before I start my presentation, I would like to acknowledge and thank my professor Praveen Muduri for his guidance and valuable inputs throughout the course of the semester, without which I would not have been capable of completing this term paper on time. The agenda for today's presentation include the motivation for the topic, a brief introduction to home and building automation, implementation of ARM and AVR microcontroller based home and building automation, comparison between the two, and finally summary and references. Recently, the comfort of living has become a priority for vast majority of the population. One of the many ways of enhancing the levels of living is through home and building automation. This is realizable due to the enhancement in technology in the field of embedded systems. This development in technology must be made available to all, especially the elderly and the disabled. The automation system must be made user-friendly such that it is easy to use even for the undereducated. Finally, we must focus on the reduction in the developmental cost and hence the cost of the automation system that needs to be reduced. Home and building automation is an idea that has existed for a very long time and has great scope for improvement in the future. As said earlier, it enhances the comfort of human life, greatly reduces the power consumption, and also provides a reasonable levels of security. Using automation system, we can control the status of the devices that are connected to the automation system. We can also control the performance levels and metrics of these devices that are connected to the system. The mode of communication in the automation system discussed in this presentation is a wireless communication. In the paper, home automation using ARM and AVR microcontroller are discussed and are compared. Any automation system has three sets of devices: the input device, the control device, and the device that are to be automated. In the paper shown below the slide, ARM microcontroller is used as the input device. ARM7 microcontroller acts as the control device, and the devices to be automated include lights, fans, air conditioner, and so on. The mode of communication here is via Bluetooth. The input device ARM9 is interfaced with the graphical user interface device to provide the user a friendly interface. This simply acts as an input remote control that is Bluetooth enabled to the user. The GUI shows the different options available on the screen. The user can choose and manipulate them only if the user is authenticated via a password or an authentication code. The communication between the ARM7 and ARM9 takes place through Bluetooth interface present in them. Since the Bluetooth is used as a mode of communication, the coverage is very less, but the cost is greatly reduced. This disadvantage can be overcome using Ethernet or Wi-Fi mode of communication, but they require a special interface that needs to be connected to the ARM7 microcontroller in order to do so. Here figure 1 shows the ARM7 microcontroller to which the devices that needs to be automated are connected. The second figure, ARM9, shows the ARM9 microcontroller to which a GUI interface is connected as shown in figure 3 that helps the user to input on the screen provided in the GUI. The second type of microcontroller is the AVR microcontroller implemented through ATmega 88. It has three layers, namely the input layer, the control layer, and the actuator layer. An Android smartphone or a PC browser in this case acts as an input device. It has a user-friendly interface and hence widely used as the input device. The Atmega 88 is the control device connected to both the input device and the device that needs to be automated. The communication medium in this case is via Ethernet or Wi-Fi. Atmega 88 cannot directly communicate in Ethernet or Wi-Fi communication medium. Hence, they require an Ethernet interface like ENC28J60 and a mug jack circuitry. The communication between Atmega 88 and the actuator devices, which is the devices that needs to be automated, follow a serial peripheral interface mode of communication. Figure 4 shows the block diagram for the working of AVR based automation system. The figure 5 shows the Ethernet interface that is required to communicate between the input device and the microcontroller, or the microcontroller and the actuator. The communication between the microcontroller and the actuator takes place as a serial peripheral interface mode of communication, which is shown in figure 6. ARM based comparison between the ARM based and AVR microcontrollers. ARM based microcontroller can be a 32-bit or a 64-bit device that supports UART, USART, SPI, LIN, CAN, DSP, USB, Ethernet, SAI and IRDA modes of communications. They are based on a RISC instruction set. They possess a good level of speed of 1 clock per instruction cycle. They follow the modified Harvard architecture, but they were introduced using von Neumann architecture at the beginning. They consume a very less amount of power. They have a vast community with a large number of vendors like Texas Instruments, Apple, Nvidia, Samsung, and so on. They have flash memory, SD-RAM, and EEPROM for memory. They are used for high-speed applications at relatively low cost in real time. The AVR microcontroller can be a 8 or 32-bit long that supports UART, USART, CAN, USB, SPI and I2S modes of communication. As you can see, AVR microcontroller supports less when compared to the ARM microcontroller. The AVR microcontroller also has a RISC-based instruction set. They have a pretty good speed, the same as that of the ARM microprocessor, which is 1 clock instruction per instruction cycle. They follow a modified Harvard architecture, same as the ARM microcontroller. They consume relatively low power and they possess a very good community, but not as vast as the ARM microcontroller, and the vendors that provide the AVR microcontroller is only Atmel. They have a flash, SRAM and EEPROM memories. They are used for cheap, efficient and effective performance, especially in automobiles and in robotics. Compared to ARM and AVR microcontrollers, ARM can be used for low cost applications in automation. If more number of devices need to be connected to the microcontroller, then AVR microcontroller can be used. So to summarize, we saw the need for automation system, which is to enhance the level of living, especially to help the elderly and the disabled people. We looked at the ARM based microcontrollers that are used in automation of home and buildings using ARM7 and ARM9 microcontrollers, and then we saw AVR based microcontrollers using Atmega 88, And finally we looked at a brief comparison between these two types of microcontrollers. These are some of the different references that I used to write my term paper. If you have any questions, please post it on the comments below in the link. And finally, thank you everyone for listening to my presentation, and that would be me.